How did China decline the UK's PS 18 billion high-speed railway project, and what led them to make such a decision? What can we learn from Nanlong's incredible 9-hour construction of Nanlong High Speed Station, which required meticulous organization, expert input, and collaboration among stakeholders? Did they manage to divide 1,500 workers effectively using cutting-edge construction techniques that resulted in remarkable precision? Additionally, what impact has this had on the local economies as a whole, as well as lessons we can draw from its management and environmental safeguards? Delve into China's amazing high-speed railway infrastructure story as you discover why major refusal occurred. Nanlong's remarkable 9-hour construction of its high-speed railway station wouldn't have been possible without extensive planning that involved meticulous organization, expert input, and collaboration between various stakeholders. Planning was critical in the successful execution of this project, with several key aspects contributing towards its smooth execution. Selection of an effective construction proposal. In advance of starting construction, 10 different proposals were rigorously assessed to select the most cost and time-effective plan. This involved reviewing each one of its feasibility, risk, costs, and potential benefits before choosing one based on factors like minimal disruption to local communities, effective resource use, and completion within 9 hours, among many others. Participation of government and infrastructure experts. Chinese infrastructure construction experts were essential in overseeing this project successfully. Their extensive expertise enabled them to recruit 1,500 workers as required and made sure that each one was sufficiently prepared and skilled for each task at hand, as well as provide technical guidance, optimize resource allocation, and monitor its overall progress. Preparing the local community. With construction taking place during night hours, it was crucial that residents were made aware of potential noise or disruption caused by this project. Surprisingly, most were highly supportive and acknowledged its significance for city development, something essential in making construction go smoothly without major objections from community members. Nanlong High Speed Railway Station's remarkable completion within 9 hours stands as a testament to efficient organization and the strategic division of tasks. This approach was essential in making construction run smoothly and swiftly. Key aspects included breaking up workforce into teams for specific tasks, as well as maintaining seamless communication among groups and collaboration among them. Division of 1,500 workers into 7 groups. To optimize efficiency and productivity on this project, all 1,500 workers involved were strategically divided into 7 groups to optimize efficiency and productivity. Each group consisted of skilled laborers, machine operators, and engineers in order to facilitate execution in different aspects of the project simultaneously. This arrangement allowed rapid problem solving, as well as quick adaptation to any unexpected obstacles throughout construction. Allocation of tasks by group. Each group was given specific tasks to focus on in order to work efficiently and targeted, using all their expertise while concurrently completing different components of the project simultaneously. This strategic allocation helped achieve our ambitious 9-hour construction timeline, maintaining efficient communication among teams. One of the primary obstacles of organizing such an ambitious project was maintaining clear and effective communication among its various teams. To address this, an efficient real-time information sharing system was instituted, which enabled teams to coordinate efforts more easily without duplicating work, quickly address any issues encountered, and effectively addressed any challenges during construction. Regular progress reports and briefings also took place to ensure all groups were working towards the same goals and working towards their shared vision of success. Nanlong's high-speed railway station's incredible completion within 9 hours was made possible due to the cutting-edge construction techniques and machinery utilized. Utilization of cutting-edge technologies helped speed and ensure precision during its completion process, and achieved unparalleled speed and precision during completion. Utilization of excavators and road trains. A key aspect of the construction process was employing 36 excavators and 20 large-scale road trains to transport materials quickly. Excavators also enabled efficient resource usage while their precise measurements ensured accurate alignment between tracks and platform surfaces. Construction measures aim for millimeter precision. One of the challenges when creating a high-speed railway station was aligning all tracks and platform surfaces within millimeter accuracy, necessitating laser measurement equipment in order to accurately align each surface to specific standards for optimal train performance and an easier, smoother journey for passengers. Specialized laser equipment was utilized here, as such for optimal train operation as well as a smoother journey experience. On-time delivery and use of construction materials. A key aspect of construction was making sure materials arrived quickly and were used effectively. care was taken in planning to ensure materials would arrive before construction started. Teams were then formed to monitor this aspect, further streamlining the construction process. Innovative construction techniques to optimize efficiency and speed during the construction process. Various innovative construction techniques were utilized instead of building an entirely new high-speed rail station from scratch. Instead, extending an existing station was decided upon. This reduced construction costs and time while simultaneously decreasing environmental impact for the project. Furthermore, similar to military operations, the entire construction process was organized around organization, coordination, and efficiency to maximize speedy progress and minimize environmental impacts. Nanlong High Speed Railway Station's completion within 9 hours has had an enormously beneficial effect on China's local and national economies, sparking increased tourism, improved transportation infrastructure, and expanded economic opportunities for local communities and beyond. Increased tourism. With its conventional high-speed railway station connecting cities quickly, more tourists have visited our region than ever. This has contributed to greater economic activity as local businesses benefit from an influx of customers. Additionally, with enhanced transportation infrastructure providing easier access to tourist sites, tourism has experienced further boost. Improved transportation infrastructure. The high-speed railway station construction has significantly enhanced the region's transportation infrastructure, making traveling between cities faster and easier for residents seeking employment opportunities, education programs, healthcare, and any essential service more accessible, as well as aiding goods movement, resulting in economic development and growth. Economic opportunities. The construction of the high-speed railway station has opened up new economic prospects in the surrounding region. Thanks to improved transportation infrastructure, businesses are more easily connected with suppliers and customers, resulting in greater economic activity overall. Furthermore, creating jobs through its construction provided income to local workers, thereby further contributing to its development and overall benefiting from regional economies' growth. National impacts. China is already enjoying significant national effects from their high-speed railway network, with 2/3 of the global high-speed lines running across their territory, and most recently finished construction in Nanlong Station, further solidifying their position as global leaders of high-speed infrastructure, as well as becoming one of Asia-Pacific region's premier powers. While China's 9-hour high-speed railway station project was an astounding engineering achievement, its potential environmental effects must also be taken into consideration. Large construction projects may cause irreparable environmental harm if appropriate safeguards are not put into place. As a result, it's essential that an impact assessment be conducted, as well as ways of mitigating negative consequences of any project of such scale. Air pollution. One of the primary environmental concerns with large-scale construction projects is air pollution. Heavy machinery use and transportation of construction materials can produce significant emissions of particulate matter and other pollutants. In order to combat this situation, measures such as using low-emission equipment or dust control measures may need to be considered as ways of combating air pollution. Noise pollution. One potential environment repercussion of any project is noise pollution, caused by heavy machinery use and continued construction activity that exceeds safe threshold levels, resulting in adverse health and wildlife consequences. To combat this effect, measures such as noise barriers or work restriction during vulnerable times of day should be implemented as quickly as possible to ensure positive impacts are realized. Habitat destruction. Large-scale construction projects may lead to the destruction and displacement of natural habitats and wildlife, necessitating measures like restoration and relocation in order to remedy this impact on nature, such as avoiding construction in areas with high ecological value or designing the project in such a way as to minimize its effect. To mitigate such loss of wildlife populations and damage, measures like habitat restoration or relocation of species should be implemented into projects designed with this in mind. Alternatively, projects could aim for less impactful designs by avoiding construction near high ecological value areas altogether. Waste management. Construction generates vast quantities of waste that, if mismanaged, could have significant adverse environmental consequences. To combat this challenge and address it effectively, recycling construction materials and disposing of hazardous waste properly should be implemented as measures against this phenomenon. China has successfully completed the 9-hour high-speed railway station project, underscoring their dedication to investing in high-speed railway infrastructure. China boasts the world's largest and most used high-speed railway network, with 2/3 of total worldwide high-speed networks being located there. Further expansion plans exist both domestically and globally for their network in future years. Domestic growth. China has set itself the goal of expanding its high-speed railway network by 2035, more than double of what consists currently, reaching 70,000 kilometers long and creating jobs as part of an economic expansion efforts. Furthermore, expanding railway services will improve connectivity among cities and regions, while simultaneously aiding goods transportation for additional economic advancement in China. International expansion. China has recently turned its eye towards international high-speed railway infrastructure projects, having already constructed them in various countries such as Indonesia, Thailand, and Laos, and now considering building lines in Malaysia and Russia as part of its Belt and Road Initiative, which seeks to promote economic development through infrastructure investment and regional integration. Technological advancements. China has ambitious high-speed railway infrastructure plans, and to support them has also invested heavily in technological innovation. For instance, they are creating a high-speed train capable of traveling up to 600 kilometers per hour. Other investments include maglev trains and intelligent transportation systems to further optimize efficiency and ensure the safety of their high-speed network. Sustainable development. China remains committed to sustainable development as its high-speed railway network expands, investing in renewable energies like wind and solar to power its railway network, as well as adopting policies encouraging use of electric cars, as well as public transit modes. China's 9-hour high-speed railway station project serves as an instructive example for future large infrastructure endeavors, offering invaluable lessons about efficient project management, effective stakeholder coordination, and environmental safeguard implementation. Efficient project management. The successful completion of the 9-hour high-speed railway station project within 9 hours exemplifies the importance of effective project management. With thousands of workers deployed and hundreds of pieces of heavy equipment deployed at once, careful planning was key in making sure this ambitious infrastructure project stayed on time and within budget. Future infrastructure projects may benefit from taking this same approach with careful coordination among all parties involved to ensure their projects run on schedule and under budget. Successful interaction between stakeholders. Completion of the 9-hour high-speed railway station project required collaboration among numerous stakeholders, government agencies, construction firms, and residents of local communities among them, from various backgrounds. Effective communication and cooperation were critical in making sure it ran without major interruption. Future infrastructure projects can benefit by prioritizing effective coordination among stakeholder groups early and engagement of local communities as part of effective stakeholder coordination plans. The successful completion of the 9-hour high-speed railway station project illustrates the significance of adopting suitable environmental safeguards during any construction project of this scale, especially those with significant air, noise, habitat destruction, or waste generation impacts. To mitigate such negative environmental consequences effectively, suitable environmental measures including low-emission equipment such as low-noise barriers or waste management plans should be utilized.